All right, folks. Sorry for the delay there. Had to get things set up. As you noticed, the backdrop is a little bit different today than it usually is for my live streams. Currently broadcasting live from my office here at the National Center for Atmospheric Research in Boulder. Not a particularly glamorous backdrop, but the internet quality is pretty good, so hopefully no major dropouts. Although I don't have all of my fancy audio equipment here, so the audio quality might be at the slight cost for that transition today. But welcome everybody to an Ask Me Anything version of my office hours. I don't have a highly structured schedule for today. I have a few things I can definitely discuss depending on the level of interest, but generally speaking, I wanted to leave a lot of time for questions from the crowd, from the broader audience. And on any topic related to weather or climate, or even somewhat peripherally weather or climate related topics. So feel free to drop those in at any time into the chat section. That's what I'm going to be checking for what we're going to be discussing during the hour. One thing I actually wanted to add into this setting, into the comments briefly before we get started with the audience questions, is a fairly remarkable YouTube video from a tornado that occurred. Let me just make sure I have the right link here. This is footage from mainly from a drone and from ground level of what I actually personally think is probably the most incredible tornado footage I've ever seen. It was taken on Monday, I believe, in Iowa. By drone and automated camera stabilization imagery from aloft of a multi-vortex tornado going through a wind farm in Iowa. Pretty extraordinary. If you have even a passing interest in weather or geophysics or natural hazards, this one is definitely worth checking out, and the link should be in the chat now. Won't spend too much time talking about it. Just so you know, this is not footage of a tornado going through a major populated area, so it is, for the most part, out in an open field, if that's something that you might not want to watch if it was video of devastation. This tornado did go on to produce some pretty devastating damage in a town downwind, but this is not footage of that occurring. This is, I don't believe the tornado was harming anybody specifically at this point. It is genuinely amazing footage of a multi-vortex tornado, kind of mesmerizing. And the other thing that and it looks like this is one of the questions that is coming up, so actually I'll just wait to answer that in the comments queue. One thing I also thought I would announce at the beginning of this session is that if you liked last year's weather and climate desk calendar, there is a new one for 2025 that I think is now available for pre-order. And I'll add that link to the chat right now as well. There's also a discount, I believe, from the publisher if you use the coupon code NEW15. That is NEW15 for pre-ordering this weather calendar. Unfortunately, this is the second and final year of this my extreme weather and climate calendar series, because the publisher unfortunately decided that the sales were not good enough to justify continuation of the series. So something of a limited edition, the 2025 version will be the last one. So it is updated from the 2024 calendar. There's a lot of new entries, including some events that actually occurred in the past 2 years while I was writing the previous calendar. But more additional historical trivia and lots of weather and climate science snippets, 100 words in length or less. Apparently the publisher, some of the most common feedback is there was too much information. So perhaps I should have written it in book form. Anyway, the 2025 calendar is available for pre-order. You can get a discount if you use that coupon code now. And I'll keep people updated on how that's going over the next couple months, as the publisher has probably some additional sales. Although, to be quite honest with you, I think that they're all about the same. They're all about 15% off. One other thing that I wanted to philosophize on a little bit, reflecting on the last live session where I talked extensively for almost 2 hours. If you're interested, it's all recorded, on the current discourse surrounding climate change optimism versus pessimism, and what we can say about where we're headed in terms of how much warming we're likely to experience, and how that's a complicated question because it may not even be primarily a geophysical science question, but more a question of geopolitics and economics in terms of how much more carbon we emit into the atmosphere, and what my personal views were on where we're headed, and how easily it even is to discern where we're headed and who can speak authoritatively on that or not. But the thing I wanted to reflect on just briefly was how divergent the feedback was that I received in the wake of that session 2 weeks ago. And actually, all of it has been polite and constructive. So this is not me emphasizing that there's been hate mail and praise. No, although I do get a lot of both of those things, for better or for worse, in my inbox. But I'm specifically referring to what people got out of it. And I've gotten an almost equal amount, fairly voluminous amount of both, of feedback that I was essentially overly optimistic, and also that I was overly pessimistic. Almost equal amounts of feedback. And I think that's interesting because of what it says about sort of our collective prior assumptions about where we are and where we're headed, our collective assumptions about, what geopolitical realities may or may not exist, and, the level of understanding of uncertainties in all of these. It was literally a 50-50 split among dozens of pieces of feedback that, I was either much more optimistic about the future than some folks had assumed, and dramatically more pessimistic about the futures, apparently, than others had assumed. I take that as a relatively good sign, because I don't think I would not characterize myself as either a climate optimist nor a pessimist. I try to be a climate realist, and sometimes that term is co-opted on the pessimistic side to say that we're all doomed and everything is going to fall apart. And I also don't think that's accurate, but I do think we need to be honest about the very real downside risks of getting unlucky, either with, frankly, geopolitics or emissions trajectories, or just geophysics. We could get unlucky with the continental ice sheets melting faster than expected. We could get unlucky. That 1 in 20, 1 in 30 chance of the Atlantic overturning circulation rapidly slowing or collapsing. We could get unlucky. Climate sensitivity, the amount of warming per increment of greenhouse gas accumulation, could result in a level of warming that is much higher than the median estimate. The current estimates in the scientific community vary by a factor of 2. So, we could get lucky or unlucky there too. And my point is, I don't think we should presuppose good or bad outcomes, given that the range of uncertainty is large. We could get lucky, we could also get unlucky, and the current median trajectory is still an alarming one, though not one that leads to the end of the world. I think all of these things are complex realities to hold in mind simultaneously. I struggle with them too, because there is some contradiction in terms, and I do find myself oscillating from one perspective to another. But it was interesting to me that the feedback was almost 50-50. I didn't think you were going to be so optimistic, and I didn't think you'd be so pessimistic. Interesting food for thought. So that's about all I've got for the monologue portion right now. I do want to dive into the questions. So there are already a couple of good ones that I think will take some time to address. And so feel free to add more the whole hour. We still have 45 full minutes for the interactive Q&A, and I'm going to dive into that now. First question is about what I think about the intense Atlantic storm season that NOAA is predicting. So this refers to the NOAA seasonal tropical cyclone, in other words, hurricane outlook for the Atlantic basin this year. This is, of course, less important for California directly, although it may affect California indirectly in the sense that some of the very same insurers who are pulling out of the California home insurance market due to perceived wildfire risk are the same ones pulling out of the insurance market in places like Florida and the Gulf Coast because of perceived rising risk of hurricane-related losses. So the decisions that these insurers are making in California are not unrelated to what happens in Texas or Florida in this case. And the prediction from NOAA, just to briefly summarize, is actually quite consistent with the prediction from virtually every entity, private, academic, or public, that makes hurricane predictions, that this is likely to be a hyperactive hurricane season in the Atlantic basin. In fact, some entities that make these predictions have predicted explicitly that this will be the most active, most extreme hurricane season on record. Some groups are a little bit less out there in the tail, but 100% of predictions have been for a moderately to extremely above active season. No one is predicting a near to below active season, so there is expected to be a very high ceiling on both hurricane activity and intensity this season. Does that mean there will be a lot of devastating hurricane landfalls? Not necessarily. You could conceivably have the most active hurricane season on record, and all of those storms could reach Category 4 or Category 5 status and recurve fairly harmlessly out to sea and dissipate in the cooler waters west of Europe without really causing much harm. And it could still then be the most active hurricane season on record. But here again, invoking luck versus unluck, I guess, that would require a pretty remarkable stroke of good luck, in the sense that the more strong hurricanes you have out there, even if it's a somewhat stochastic or random process, the higher the odds are that more of them make landfall or affect island nations in some way than in a year where there are very few of them. So we do expect there to be an unusually high number of hurricanes and tropical storms this year in the Atlantic basin. We also expect them to be significantly more intense than usual. So not just more storms, but probably more importantly, and maybe even more predictably, more intense storms. Why is that? Why is this prediction the way that it is? It's mainly because the oceans are just ridiculously warm. Bathtub warm, maybe even approaching hot tub level warmth in some places. So the ocean temperatures are 3 to 7 degrees above average. That is a very large temperature anomaly for an ocean body of water, because of course it takes a lot more energy to heat a given volume of water than a given volume of air. So it says a lot when you're several degrees above average, let alone 5+ degrees above average across broad regions of ocean. And this is true all the way from the eastern Atlantic off the coast of West Africa, all the way westward across the entire basin into the Caribbean and into the Gulf of Mexico, including the water right along the shores of all of the Gulf Coast states of the U.S. and all of the island nations in the Caribbean. So all of these places are going to be at risk of particularly intense hurricanes this year. So how hot are the oceans? That essentially sets the ceiling on how intense hurricanes or tropical cyclones can become. It doesn't guarantee strong cyclones. In fact, this is somewhat analogous to the notion that in a warming climate, California precipitation, we still don't really know if it's going to increase or decrease on average. It might do a little bit of either. But we do know that the most extreme events are likely to become a lot more extreme, both on the wet and the dry side, even though we don't really know how the average is going to change. Somewhat analogous to this hurricane potential intensity question, because the ocean temperature sets the ceiling on how intense hurricanes can become. Deep layers of warm ocean water are effectively hurricane fuel. So the hotter the water is, and or the deeper the layer of that hot water, given other conditions becoming favorable, the more intense hurricanes can become. And this year, there's a record amount of warm water both at the surface and at depth. So that critical ingredient, hurricane fuel, is at record levels. I've never seen it as high as it is this year, even last year, which was record at the time. Then, on top of that, we have a transition from El Nino conditions in the tropical Pacific Ocean to rapidly developing La Nina conditions in the tropical Pacific. El Nino is now officially gone. La Nina is not yet officially here, but we're seeing the early signs. Why does what happens in the Pacific, though, affect the Atlantic hurricane season? Well, the reason is indirect. Even though La Nina brings unusually cool water to the eastern equatorial Pacific Ocean, and again, hot water is required for hurricane fuel, what it does in the Atlantic is through large-scale atmospheric teleconnections, through indirect forces operating at a distance, lagged over time. The atmospheric state that is induced by La Nina essentially reduces the amount of vertical wind shear indirectly over the Atlantic basin. And wind shear is a hurricane killer. It sort of decapitates developing hurricanes and tropical cyclones if it's too strong. So you want, for a very strong hurricane or for numerous hurricanes, you need the hottest oceans possible and the lowest wind shear possible. This year, we certainly check the hot oceans box. They're hotter and deeper than they've ever been before. And now it also looks like we're going to check the low wind shear box thanks to this developing La Nina. That hasn't materialized yet, but we expect that wind shear to really decrease later in the year when La Nina starts to get going. And of course, that's precisely close to the peak of hurricane season, which is more in August and September. We haven't even officially started the season yet in the Atlantic. So in terms of the ceiling on how intense storms can become, the warm ocean box is massively checked. In terms of the ability for the atmosphere to inhibit those otherwise intense hurricanes is also checked because we're likely to have lower wind shear thanks to La Nina. And then there's the third piece, which is a bit of a wild card, which is how many storm seeds will there be? Hurricanes usually don't just form out of nowhere. There needs to be some initial kick or perturbation to the atmosphere, often in the form of a weak spin of low pressure or just a random cluster of tropical afternoon thunderstorms can sometimes even be enough if they're strong enough. Something that starts to spin cyclonically, even weakly, because that initial cyclonic spin is what you need to start to aggregate and extract that energy in the warm tropical oceans. How many of those storm seeds, those initial spins, will actually materialize is not easy to predict from year to year, and so that remains a bit of a wild card. It doesn't affect the potential intensity of the storms that do develop, but it does affect how many storms there might actually develop. And so essentially we know that this year it's like a loaded spring. If there is, to the extent that there is hurricane development, it's likely to be intense. And we also know that thanks to the wind shear component, there is likely to be a favorable environment for storms to maintain their strength if they do develop, thanks to La Nina. We don't necessarily know how many hurricane seeds in the form of initial disturbances there will be, but that's not really a predictable element anyway. So 2 out of the 2 predictable elements are screaming, we will see a lot of hurricanes and probably a lot of intenser hurricanes this season as well. The third part that we can't really predict anyway, well, we can't predict it, so we don't really know what's going to do. But 2 out of the 3 main elements are pointing very strongly in the direction of an active season. That's sort of what I'm thinking about. So the NOAA prediction out today is no surprise. It's very consistent with predictions made by other groups. And although we don't know exactly how many of these storms might make landfall, it's a game of Russian roulette. And this year there's more likely to be more bullets in the chamber. Maybe not a great analogy given the state of things right now, but the way to think about it, yeah, maybe soccer or football is a better analogy. This year there's likely to be a lot more shots on goal. So don't know exactly how effective the goalie is going to be, but even with the world's best goalies, if you double the number of shots on goal, you're probably going to get more points. And if you have a better player making those shots on goal. Maybe an analogy for the strength of those storms. So there's likely to be more of them, and they're likely to be more powerful, more effective. So this could be a banner year for Atlantic hurricanes. It's actually pretty concerning. And this might have broader implications outside of the hurricane zones for the insurance market, which faces this crisis of stability due to the confluence of increasing natural hazard risk due to climate change, but also just because we continue to build more and more stuff directly in harm's way. And that would have been an increasing problem even if we didn't have climate change. But of course, these two things multiply each other. The question often is this climate change, or is this urban expansion, or is this people wanting to build beach houses on the Gulf of Mexico, or view houses in the foothills of California in places at great risk of wildfire? The answer is it's both. We are seeing more extreme wildfire conditions. We are seeing more rapidly intensifying hurricanes and a higher ceiling on how intense hurricanes can become. But simultaneously, in the same moment, we're also building furiously more and more houses in exactly the places that are at the highest risk of these things and would have been at very high risk even 100 years ago. So the answer is it truly is both of these things. And it varies from place to place as to sort of the weight you might be able to place on each factor, or climate change versus other things. But they're both essentially there everywhere. And so it's not an either-or proposition. All right, next question from Anthony Edwards, San Francisco Chronicle. Do you have a hunch that Central and Southern California and the desert Southwest may be heading toward a period of possibly of years of dry weather? La Nina tends to persist for a couple of years. Does this worry you? Well, to be clear, we don't really have very good year-to-year predictability of precipitation in general. We have some signal at seasonal scale. I do tend to think that this coming rainy season is probably going to see a tilt towards drier than average conditions in Central and Southern California and the Southwest due to what could be a quite significant La Nina. So we have a little bit more ability to say that right now about maybe this coming fall and winter than we might otherwise, because of the strong indication of a strong La Nina, which does tend to predispose this region to have drier conditions. But I don't really think we can say anything about multi-year conditions at this point. We have seen a tendency of La Nina events recently to persist for multiple years, but that didn't always used to be the case. There were a lot more one-off events in the 20th century. So it's not yet clear, and this is part of a deeper question about what climate change is doing to ENSO, or the El Nino Southern Oscillation, and by extension, both El Nino and La Nina, that we don't know exactly how that's going to change. Climate models suggest we should see more El Nino-like conditions on average. We haven't seen that yet. We've seen a trend towards more La Nina-like conditions. Now, the burning question for climate science right now is, are the models wrong? Or did we just get unlucky? Is this just a random sequence of variability? I've talked about this before, and there is genuine scientific uncertainty. We don't know. This could be a place where the models are wrong. It also could be a place where we just had this really weird sequence of variability where natural sequence of weather and climate opposed the human-caused trend towards more El Nino-like events. If the latter is true, then will this recent trend reverse? Will we start seeing more and more isolated La Nina events and a trend towards more El Nino-like conditions in the coming decades? We don't know. There's an interesting new hypothesis that in certain modeling frameworks, and this is, by the way, late-breaking science that I've seen, it's not peer-reviewed or published yet, so I won't be specific about it. But generally speaking, that when you use very high-resolution models, not just atmospheric models, but also ocean models, and couple them to climate models, what you actually get is a trend in the initial decades of global warming towards a more La Nina-like state at first, but then a sudden reversal toward a more El Nino-like state later. And some of these modeling experiments suggest that that might happen in the 2020s or 2030s on our current trajectory. That sure would be interesting because it would match what we've seen, which is historically a trend toward more La Nina-like conditions, but then There is this long-term expectation from climate models that in the future there'll be more El Nino-like conditions on average. Now, there's this new modeling framework that actually suggests that both things might be true, that we might initially have one effect, but then transition towards something that is qualitatively different later as warming progresses. That's an interesting hypothesis. But all of this is to say, I don't think we can rely on the fact that La Nina will last for multiple years. I do think by the time we get to September or October, there'll probably be a pretty clear tilt in the odds towards drier than average conditions. So I think we probably, in all likelihood, will not see a third wet winter in a row in Central and Southern California and the Southwest broadly. Never say never. As I mentioned, it's always a tilt in the odds, but I think that the likelihood of a third consecutive wet winter is quite low, both just statistically and in light of this specific information about the likelihood of a pretty strong La Nina this year. But I don't think we can say much about multi-year dry periods. We just don't really know. We do know in the warming climate that we should probably expect to see more wet and dry extremes in the western U.S., both wet and dry. What I do think we're likely to trend toward is another round of much hotter conditions than the recent baseline in California. So we've gotten a bit of a reprieve. The 2010s were terrible in California from both a temperature, drought, and wildfire perspective. 2 historically severe droughts, multiple years that broke previous records for the hottest year on record, record-breaking heat waves in different regions, record-breaking wildfires, record-breaking all the time, everywhere in terms of hot, dry, and burning. And then, starting in about 2021 through now, we've gotten a break. It hasn't been as extremely hot for the most part. Wildfire activity has greatly calmed down relative to the previous decade. I think a lot of folks assume that maybe the 2010s were a blip on the radar. I don't think they were, just as much as I don't think the last few years are unrepresentative either. I just think that these swings between extremely dry and extremely wet are what we should be expecting. So the pendulum is going to swing back toward dry and exceptionally hot at some point, and back again towards very wet later. This coming year, does not look likely to be another relatively mild and wet year. I think that's not a likely outcome for 2024, 2025. And I think we may start to see that transition this summer at some point. And I'll leave it at that for now because I think there's another question that we'll get more deeply into that specific question in a little bit later. So I'll come back to that. Next question, there's a question about how recently in Alameda, California, the city of, I believe, I'm somewhat familiar with this, halted a cloud brightening study in the Bay Area over health concerns. What are your views on that? Are there possibilities that it will work in the future, and is it safe? Well, with the very important and large caveat that I am not an expert on either cloud brightening, geoengineering, or this specific experiment, I am broadly familiar with all of these things and the specifics of it. This was a very small scale experiment. I believe it was occurring on the deck of a decommissioned Navy warship in Alameda. And the extent of the experiment was mostly limited, essentially, to, granted, it's a large ship, but it was mostly limited to the extent of the ship itself. And again, to my understanding, this experiment was essentially just one emitter launching some salt crystals, and in this case, the specific salt was literally sodium chloride, so far as I understand it, so literally table salt, into the air immediately above the ship just to see if it produced a little bit more coastal fog or stratus in the immediate vicinity of the salt emitter. That's my understanding of the extent of the experiment. It was extremely small scale. And I think, to be quite honest, it's very unlikely that it was causing anybody any harm, given A, the extremely localized nature of it, and also just what they were putting into the air. It's small particles of table salt, which is not different from what is in the air when an ocean wave breaks, for example. That's why you smell the sea air, the salt air. That's literally what it is. So I think it's an experiment. I'm not even sure that they technically qualified it as an experiment. It's almost an exhibit, or it was before it got shut down. I don't think that there's it's very unlikely, I think, that it was producing harm. On the other hand, I do think it's incredibly important to have community buy-in for any sort of experimentation scientifically that even theoretically could affect people in adjacent areas, especially given the long history of that not happening in contexts where there actually were real risks that caused harm to a lot of people when that experimentation was done without their consent and without much thought to potential unintended consequences. So I get it. I understand the reticence. I do think in this instance it was very likely safe and probably not really affecting much of anything. In fact, it was so small scale, I'm not even really sure what they were testing, because it's just so small scale that it probably wasn't affecting much of anything. But I think it does get to this broader sense about consent and geoengineering. And there are a number of companies, for example, around the world that are deciding unilaterally to test forms of geoengineering that are arguably less benign and less localized. So far, I think that this is an issue on relatively small scales, but I do think that it's going to become a much bigger issue pretty quickly. In fact, there was just an announcement recently by Bill Gates and the Gates Foundation that they're apparently going to be pursuing solar radiation management pretty aggressively. I personally don't think that's a good idea, especially for a private entity that doesn't have a great deal of oversight of how to pursue these things. I am not of the opinion that research in itself on different geoengineering interventions is inherently a bad thing. In fact, I think we actually do need to understand it. I actually am pretty conservative in that I think that a lot of forms of geoengineering probably are not a good first-line approach to solving a lot of these problems, partly because in a lot of ways they're unlikely to work at scale, but also because they help us avoid addressing the underlying problem of actually reducing emissions and slowing the underlying warming. Geoengineering and solar radiation management is an incredibly big topic that's probably better suited for another day, but I do think that there are a lot of ethical concerns, and I am not convinced that a lot of the private entities that are currently entering the space are adequately interfacing with them. And I actually don't think the Alameda example is a particularly strong one, in the sense that, to my knowledge, this was a very small-scale experiment using materials that are essentially completely innocuous. Again, this is, please correct me if the details are incorrect, and that they did actually ask for permission, although perhaps not in the right venue, and this may be where the conflict lies. The challenge is actually there is not a lot of regulation in this space, and so sometimes it's not very clear what the framework is for getting community buy-in and for formally asking for permission. Who do you ask if there's no real formal framework for doing this? This is another big question, and perhaps it's good that it's coming up now with an experiment that probably didn't cause anybody harm anyway, before we get to the point where there is larger scale experimentation with riskier, shall we call them, modalities. So I think that's important consideration, and I think that, well, it's maybe a very complicated topic for another day. It's interesting that this particular experiment has gotten this much attention, partly because there are probably a lot of other industrial smokestack tailpipe sources within a couple miles of that ship that are producing far more harmful emissions just in the regular course of daily business, which is an interesting thing to think about in context. But I do think that the question of consent and buy-in for these sorts of experiments, and they are going to start happening, whether we like it or not, unfortunately, I think this is something that's going to become an increasingly salient question. And this is on the innocuous end of the spectrum, I think, in relative terms, but not all of them will be. And so that I think it's important to have those conversations now. Question from Brian Washburn about the new National Weather Service Heat Risk Index and their collaboration with the CDC. This is an interesting new index. It's not perfect, but what is? The idea behind it is essentially to create a normalized or standardized product that takes into account that 100 degrees doesn't mean 100 degrees everywhere in terms of the level of human and environmental impacts that result from it. For example, 100 degrees with a dry desert heat is quantitatively and qualitatively a lot less extreme and way more manageable than 100 degrees in a swamp in Mississippi with very high humidity, for example. Those 200-degree days are not remotely equivalent in terms of the risk to human health and the environmental considerations. And so accounting for humidity is one big piece of what the heat risk is. I'd take 110 degrees and a dry heat any day over 90 degrees and high humidity, but just no question. And the reason, of course, physiologically, is that it is much easier to sweat when it is a dry heat, and so the mechanism by which human bodies cool themselves is far more effective when there's a dry heat, because you can evaporate a lot more water off of your skin, and you can cool yourself through that evaporation via sweating as long as you replenish that supply with water and electrolytes. There is a level of a combined heat and humidity beyond which the body can no longer shed heat through sweating, and that's the level that's known as a lethal wet bulb temperature. You don't want to get there, because it means that even if you're sitting outside in the shade wearing no clothes with an infinite water supply, you can potentially overheat because you simply do not have the ability to cool your body anymore through sweating. So clearly humidity is a big part of it, so incorporating humidity is important. The other piece, too, is normalizing it by region. So even if you have apples for apples humidity, call it 100-degree dry heat. Well, 100-degree dry heat in Phoenix is pretty ho-hum. That they're dozens of days per year much hotter than that. But 100-degree dry heat in Seattle would probably be record-breaking most days out of the year. And so 100-degree dry heat in Phoenix, no big deal. Everyone's got air conditioning, essentially, with some important exceptions. But generally speaking, it's a city that can handle 100 degrees like nothing. Seattle, 100 degrees is a big problem because you do not have infrastructure that's built to accommodate that level of heat generally. People do not have air conditioning. Public facilities are not designed to accommodate the energy loads. Sometimes even railroad tracks start to bend under extreme heat. We saw that in the 2021 heat wave. So, in other words, this NWS heat index takes into account two things that factor into the anomalousness of the actual heat impacts. A, how much humidity there is or isn't. B, where you are. So how rare is this level of heat and humidity relative to where you live? Obviously, a certain level of heat and humidity in Phoenix or Houston would be very different than in Seattle, for example, or San Francisco. And then it also takes into account the time of year. So, 100-degree day, in Los Angeles in August is hot, but nothing record-shattering. 100-degree day in January is a very different story. People are not accustomed to heat. Cooling systems are not engaged, so the seasonal context matters. So seasonality, location, and the level of humidity. It's a normalized index that takes into account all of those things to produce an aggregate measure of how dangerous the heat is. I think we needed that. We can quibble about whether it's calculated correctly, but I do think it's a major step forward that the Weather Service coordinated with the CDC on this, because heat and humidity are actually the number one weather killer, if you will, in North America. It's a silent killer. More people die from extreme heat than any other weather hazard in the country. And yet most people don't even think twice about heat waves in that context. And yet they're the deadliest kind of weather event that we have. So it does make sense. I'm glad there's more focus on this from a public health perspective. Public health scientists who focus on and epidemiologists who focus on heat risk, morbidity, and mortality continually emphasize that we way undercount and underestimate these risks, and we could probably prevent a lot of illness and death if we had better measures to mitigate and prepare for and adapt to those extreme heat events. So I think that is an important step. Okay, there's a question about what is the reason behind the heat wave in Mexico. I do want to answer that, and partly because it's related to the question about what's coming next for California. So I do have one map I'll probably show. I'll do that a little bit later. Remind me if I don't come back to it, but I think I'll remember. Take a sip of water here. Question from Alex Garcia, probably relating to my earlier conversation about the Atlantic hurricane season. How deep in the vertical sense, I assume, does the Atlantic heating go? Is it the entire column as enormously warm? Well, I mean, entire column, the ocean is thousands of feet deep in some places. So no, not down thousands of feet, but in the top layers of the ocean that are relevant for hurricane season. So it turns out that the deep layers of the ocean don't interact with the surface layers of the ocean except on timescales of sometimes hundreds to thousands of years. So information in terms of the properties of the water at the very bottom of the ocean can take decades to centuries or even longer to be exchanged with the surface. So 1,000 feet down, 10,000 feet down in a trench essentially doesn't matter for hurricane season. So really, we're talking about the top 10 to maybe 100 meters, and really just the top 10 to 50 meters of the ocean. So something like 30 to 150 feet of the ocean. And that whole depth is the depth that can get mixed up within a single season, essentially, and churned up by ocean waves and stuff. And yes, essentially that whole column is extremely warm. So there is a record amount of cumulative warmth integrated over that whole top of the column. So it's not just that the surface is super warm, but it's also extremely warm at considerable depth, at all of the depths that are relevant for upwelling in this region this season. So that's the other concern, is that even if you get a couple of big hurricanes that churn up some cooler water from beneath, well, it really isn't going to be all that much cooler this year. It's still extremely warm water. So that's actually an additional piece. That vertical component is also another reason why the predictions for this Atlantic hurricane season are so off the charts ridiculous. Question from Lori: Do you see extreme types of weather as intensifying responses to global heating from a physics perspective of equilibrating heat distribution? Would extreme weather to continue to become more extreme? So I think this question is saying is essentially, is increasingly extreme weather a function of the rate of change, of the fact that the system is sort of constantly out of equilibrium at the moment, where there's a big energy imbalances because there's more energy being retained than going out, versus say we stabilized warming at 2 degrees centigrade. So say we warm another half or so degrees centigrade and the warming stops. Say we're really successful with emissions reductions. Speaking of optimistic scenarios, let's just say that for a moment. I think the question is, would we still have an elevated level of extreme weather events if warming stabilized at 2 degrees versus continuing to warm? And the answer is yes, we would still see an elevated level of extremes at 2C of warming, because the main reason why weather extremes are increasing is not because the system is out of equilibrium. It's just that the underlying processes in the system, a lot of them scale exponentially with the absolute temperature of the atmosphere. So this is the fundamental notion of the Clausius-Clapeyron relation. So there's exponential, and it is literally mathematically an exponential relationship between temperature and the water vapor holding capacity of the atmosphere. And as I've talked about extensively, and we're writing a big review paper on this right now. We just got heavy revisions back, so maybe this will be out in the world in maybe 3 to 6 months. That exponential relationship between the Earth's absolute temperature and the water capacity of the atmosphere, and I'm being deliberately vague there because it means both that the amount of water vapor in the atmosphere increases by 7% per degree centigrade of warming. In other words, it compounds exponentially, but also the water vapor evaporating capacity of the atmosphere. So the vapor pressure deficit, the evaporative demand, the thirstiness of that atmosphere also itself increases exponentially with warming. that is a function of the actual temperature of the air, not a function of disequilibrium or rates of change. And so anything related, for example, to water vapor in the atmosphere or the water vapor evaporating capacity of the atmosphere, which the more we learn is essentially almost everything that's important, extreme rain events and floods, extreme wildfire events and droughts. Turns out that the jet stream, the extreme winds at jet stream level scale with about the same level, 7% per degree centigrade. So with that same Clausius-Clapeyron relationship, it looks like severe convective weather, so severe thunderstorms, also appear to, in most cases, scale exponentially at about 7%. So it turns out that a lot of the key impacts of climate change, a lot of the extreme weather we're seeing in a warming climate, all of this is very intrinsically linked to this rather elegant mathematical relationship, but concerningly exponential relationship with respect to linear warming. And what that means is that, say we level off at 2 degrees of warming, we're still stuck with 2 times 7%, for the most part, increase in extreme precipitation events and extreme evaporation events and increasingly extreme wildfire events. Those stick with us even if the warming stops and stabilizes. Now, would they reverse if the warming actually started to decrease? Yes, they would. They would probably go decrease at roughly the same rate. It would be a 7% decrease per degree of global cooling. But that's such a speculative future at this point, meaningful global cooling, that it's almost not worth thinking about right now. But the key point is that for a lot of these extreme weather events, it's less a question of temporal rates of change or disequilibrium in the system, and it is actually a state-dependent function that is exponential as a function of the actual temperature of the atmosphere. And this is one reason why each degree or even fraction of a degree of warming is so important, because a lot of these extreme weather phenomena scale exponentially at a rate of plus minus 7% per degree centigrade or 3 or 4% per degree Fahrenheit of warming. And hopefully that answers the question. Often there's enough comments that I probably won't see the response as to whether it answered the question until well after I've answered it, but that's okay. Good questions in this session, by the way. I won't get to all of them as usual, but I do have to be a little bit selective to keep it within the hour. I might even run a little bit long already now that I'm seeing the hour, but I started a few minutes late, so let's just call it, we'll call it even. I'll run a little bit long. Question from Tim. Does the amount of Sahara desert dust in the atmosphere have an effect on hurricanes? Yes, it does. I'm not an expert on Saharan dust. By the way, it's often Sahelian dust rather than Saharan dust. It's often dust that actually comes from the transition zone between the Sahara Desert and the tropical rainforests north of the equator in Africa. So in that grassland, scrubland transition zone where there is some vegetation but also a lot of sandy soils, as opposed to the Sahara where there is mostly just sand. It is a very vast, hot, unvegetated, and largely unpopulated desert. You can get dust that comes both directly from the Sahara, the actual sandy part of the desert, but you can also get a considerable amount of dust that gets lofted from the Sahel, this mixed grassland, scrubland ecosystem transition zone. But in any case, yes, dust from either of these sources tends to get advected westwards, so the east to west blowing winds in the tropics blow this dust out over the eastern Atlantic Ocean west of Africa. And this dust can interfere with the atmospheric stability. So it can change the temperature profile of the atmosphere because it affects where the sun's energy gets absorbed, meaning that it can actually cause warming of the upper atmosphere but relative cooling of the lower atmosphere. That tends to stabilize the atmosphere, making it less favorable for thunderstorm development and hence less favorable for tropical cyclone and hurricane development. So extensive Saharan or Sahelian dust layer can inhibit Atlantic tropical cyclone formation and intensification. So if there is a lot of Saharan and Sahelian dust this year, that could be a wild card that we're not good at predicting at scale. Right now, there's not much to speak of, although that doesn't mean there won't be a couple months closer to peak season. I don't think we have good predictability of it, but it is a real wild card. It definitely, profoundly, even surprisingly so, affects Atlantic hurricane activity. And by the way, there's even a hypothesis that some of that uh, some of that elemental mineral rich dust, particularly iron, uh, as it blows all the way westward across the Atlantic Ocean to South America, with the first landmass it reaches is the Amazon, and that the iron fertilization from these westward blowing winds is an important reason why the Amazon has as lush of tropical rainforest as it does, because otherwise the tropical soils there would be too poor to support that level of vegetation, and yet it's there. One hypothesis is that a lot of that, a lot of these trace minerals are actually deposited in small but continuous amounts by these east to west winds in the tropics, blowing all the way from the dusty parts of the northern half of Saharan or sub-Saharan Africa, north of the equator, to the Amazon itself. Pretty interesting stuff. Question from Tyler. With the Canadian wildfire season starting early, what do you expect for the Pacific Northwest in general this fire season, specifically Northern California, Southern Oregon? Thanks. Well, I have had some sessions where I talked extensively, specifically about that, but I'll just briefly review it. Fire season is getting off to a rapid start, both in Western Canada and now also in Arizona and New Mexico, and I expect that to continue to accelerate in both places over the next few weeks. With the rest of the Western North America, northern Mexico is experiencing quite a severe fire season right now. I'll get into why that is in a moment. In the western U.S., I think that it's likely to be a slow start to fire season in most places outside of Arizona and New Mexico, where they're having a fast start due to ongoing extreme to severe, exceptional drought there. As the season progresses, though, I think we'll go, and this is true both for California and for the interior, so Rocky Mountains, Pacific Northwest, we will transition from what might be a near to below active season in May, June, July, to what is likely to become then an above active season thereafter, August, September, October. And that is partly because we've seen wet and cool conditions recently, especially in places like California, but also across much of the Rockies. And you've seen a lot of vegetation growth and relatively low fire activity, so there's fewer recently burned areas. A lot of the massive fire burn areas that occurred in the 2010s are now 5 to 10 years old and have seen multiple consecutive wet and cool years for regrowth, so they can support, in many cases, fire spread once again within those parameters at different levels of intensity perhaps, but under, say, a heat wave or a major wind event, they can carry a fire through them once again, so they're becoming less barriers to fire spread than they were a couple of years ago already. And the prediction that this summer might be exceptionally hot across the interior west, particularly in the desert southwest and the Rockies, but also expanding westward into California and the Pacific Northwest later in the season, particularly in August and September and October. And that this might be a weak monsoon year. There's pretty strong signals right now that this might be a poor monsoon across the desert southwest and the Rockies. So if you combine recent wet and cool conditions with lots of vegetation growth with what could be an exceptionally hot and dry summer across much of the West, maybe even breaking some records for both of these things, along with the long-term trend towards much hotter summers and lower atmospheric humidity or higher vapor pressure deficits, as I was talking about earlier, that Clausius-Clapeyron atmospheric sponge effect, I think this might be a fire season that rapidly transitions from very inactive to very active and catches people by surprise. So I think that California there'll be headlines in July. I know, every year there are. I can just see them now. There'll be some local news media headlines in July that California has seen like the lowest acreage burned in I don't know how many years, as of like July 1st or something. And that will be a completely meaningless statistic for the fire season at large, given that almost everything that's going to burn will burn probably in August or later in California. And it could, in fact, be very active because this fall in particular looks particularly hot and perhaps also drier than average in California specifically. And of course, that overlaps with offshore wind season. So Santa Ana, Diablo, Jarbo, Gap type winds occur most often from September through November in many regions. And that is precisely when we're expected to be most anomalously hot and dry this year. with following a lot of extra vegetation growth. So we have a bunch of extra growth, and then we might dry a lot of it out later this season. So I would expect a fire season that looks pretty different from recent seasons. I'll continue to talk more about that as it progresses, but that's the way I currently see things. All right, another question about the heat dome over Mexico and California. Again, I want to talk about this in a moment. I might end up closing with it as we're getting close to the end. All right, so I think that might be a good thing to close with, and I know a lot of folks are interested in it, so let me, by close, I mean I'll probably still be talking for another 10 minutes or so. So I'm going to take another sip of water, and then I'm going to share a map. I can see in the return footage that there's like a moth or something in my office behind me. I hadn't noticed that earlier. Surprised no one pointed it out. All right, so let me share. Just got to share the right screen so you see the map rather than my email. As interesting as that probably would not be. Okay. There we go. All right, so yeah, this will be familiar to longtime site viewers. Tropical tidbits. And what I want to show here, I want to talk about two things. So many of you may be aware that in recent days and even weeks, there's been a rather extreme, in fact, record-breaking, in some cases record-shattering heat wave across northern Mexico. Or really northern and central Mexico, much of the country, extending particularly in the northeastern part, but more broadly, really across, expanding to other parts, really south of Mexico into Central America, even into the tropics to a certain extent. But this map that you're seeing on screen, and I'm going to enlarge it a little bit. There we go. A little bit easier for people to see. This is going backward in time. So this is an analysis of the way things were on Monday. As you can see, this remarkable, persistent ridge of anomalously high atmospheric geopotential heights, really just meaning that extremely high lower half, extremely warm lower half of the atmosphere. And this is going forward in time. So I started a couple days ago, and now I'm going, this is 3 days in the future, 4 days in the future, 5 days in the future. Yikes. 6 days in the future, this actually gets a lot worse again from where it currently is. So we actually see a rebounding of really extreme ridging and extreme high temperatures across Mexico and Texas and southern New Mexico and Arizona. And what you also see is not as extreme over California and the West, but we do start to see an increase in ridging over this region too. And as this region expands westward, California also gets into the mix, as well as the Rockies. As we get into early June, Southern California might end up getting pretty toasty. And the key part here, California is not going to be as extremely hot as some adjacent regions. But this is the European model ensemble average for the first week in June. And this extreme tropical, subtropical heat wave continues over Mexico and Texas almost without a break, and resurges a bit across the west. Now, these are normalized geopotential height anomalies. I want to show something interesting here. This means that this is like the NOAA heat index that we mentioned earlier. This is normalized relative to the time of year and the location. So the units here are standard deviations, and of course these are defined locally. So there isn't some uniform distribution, but this is on each little grid box on this map gets its own distribution and how far along the scale of abnormalness. Essentially, this is a standardized scale of abnormalness or not. Completely normal would be 0, literally close to the median or the average value for the time of year and the location. 3 being a very large, 3 sigma, 3 standard deviations from the norm, and -3, of course, being 3 below. You start raising some eyebrows once we get above about 2 standard deviations, and above 3, it's a really big deal. So we're in this 2 to 3 territory constantly over Mexico for this period. 2 to 3 plus standard deviation anomaly is a big deal. Over California, it's not nearly as big of a deal. 1/2 to 1 standard deviation across the west. It's still notable. That's still significantly warmer than average and ridgier than average, but it's not record-shattering in this region, but it actually is over Mexico. But look what happens, and I'm going to change this to the absolute height anomaly. Well, that looks a lot different, doesn't it? And this is because in the tropics and subtropics, the standard deviation, the amount by which the geopotential heights in the atmosphere and also just temperatures of the surface vary, is a lot lower. You actually have much higher temperature variability the closer you go to the poles. Temperature variability decreases steadily as you go toward the equator, so it takes a smaller deviation from average to result, say, in the Mexico-Texas border here. This doesn't look like much at all. This is about 50 decameters. It's barely even on the positive side of the scale in terms of the absolute height difference. But in context, and that's about the same as the level of absolute ridging over California. So you might think, oh, well, it's not very impressive in either location. But if you look at the normalized anomaly, of course, it's radically different, where this is modestly above average in California and record-breaking for the same deviation over Mexico. So the context matters, and in this case, the context is that the temperature variability in the tropics is a lot lower than elsewhere. And these are middle atmospheric temperatures, but if we look at the surface, we see the same general idea that these places where there are very warm temperatures aloft, there's also unusually hot temperatures closer to the surface. And this wiggles around a bit, and the immediate California coast may benefit from some May gray and June gloom, so it won't get that hot. But across the California interior, it does look like things are going to be heating up potentially big time first and second week in June, and certainly across the interior west, with some really searing temperatures continuing in northern Mexico. The heat wave in Mexico and South Texas has been incredible and awful in that it has been an extremely long duration event, and in most of those places, it's also a pretty humid heat wave. So as you can see, actually, I think I can bring up, well, this is the precipitable water anomaly. But I'll just show this. I'll just show this with the American model briefly, and show the difference in what the dew points look like. This is a measure of surface humidity. Well, this is just an example of how much more humid it is, say, in northeastern Mexico and along the Gulf Coast in Texas, than it is across California or the desert Southwest. This is an objective measure of absolute humidity. This is the dew point. So essentially, higher values mean much higher humidity. And I mean, look at these dew points. 70, 75 degrees Fahrenheit in Texas, but in Arizona, they're only 20 degrees. This is very dry air. This is unbearably humid air, and this is where the most extreme heat wave is. So this is a very dangerous heat event for northern Mexico and Texas, and it just doesn't look like it's going to end anytime soon with this pronounced ridging. I do think that this ridging is going to expand across much of the West, including the California interior in early June, so it is going to get warmer during that period. We may even see some early June heat waves in California, but right now, it doesn't look like they're going to be extreme, but I'll revisit that if that changes. And I do expect the likelihood of that heat becoming a bit more extreme really does rise considerably as we get into August and September in California and the rest of the West. So this might be an early taste. It doesn't mean that all of June or July are going to be super hot, but it's not a great sign for the season that even in this period that was supposed to be the relatively cooler part of the summer, it does look like there is going to be a heat wave of some magnitude coming up, and it might last for quite some time across the interior U.S. So that's sort of what I'm thinking there. But the heat wave in Mexico is exceptional, and at least in the U.S., I haven't seen a whole lot of coverage of it, frankly, and I'm somewhat surprised by that. Well, maybe I shouldn't say surprised, but it's an interesting insight into what gets covered and what doesn't get covered as much in the extreme weather space. These days, there's always so much to talk about that it is something of a zero-sum game, which events get focused on. And there's been plenty of other dramatic weather with major tornado outbreaks in the U.S., for example, and severe floods elsewhere in the world. What else is new? But these extreme heat events, I think, are often underestimated. this event in Mexico and Texas is not ending anytime soon, and I actually think it's going to get worse before it gets better. And later this summer, the rest of the West, I think, is going to have to contend with more of it than it is right now. All right. All right. Well, I think that's probably about all I've got for you today. There's always an endless number of topics that can be discussed, but just to summarize a few pieces of housekeeping once again. Check out that YouTube footage I have in the one of the first comments in the section regarding that incredible, what I think is probably the most incredible tornado footage ever captured on film that from an event that occurred on Monday. Some of the footage is from the air, from stabilized drones, which is, I don't know, frankly, I don't know how they fly them that close. It is a clever way of getting close without putting a person there, so props to the videographers there. And then also, just to remind folks who didn't hear this at the beginning, that there is a 2025 version of my extreme weather and climate calendar available for pre-order now from the publisher. There is a coupon code at the top of the comments section. You can use that for pre-order off the publisher website. This will unfortunately be the second and final year of this short-lived, but I think worthwhile experiment. The publisher is not continuing into 2026. So limited edition stuff in a certain sense, I suppose. We'll just see what the next project brings. But for 2025, there will be there's an updated and revamped calendar. If you like the 2024 version, you'll probably like the 2025 version, and there's fairly minimal overlap. There are some things that are similar. There's also quite a lot of new stuff as well. And the final piece is that I am thinking about trying to have a slightly more regular schedule for these live sessions. If we can crank the audience up a little bit, I'm still hoping that folks can share this across YouTube and on social media. I'm trying to have a more coordinated social media approach. I'm going to, I think I've decided to invest in yet another expensive software subscription so I can better cross-post across social media platforms, which means that hopefully the level of content on platforms like Blue Sky, Threads, and Mastodon will improve. I have had a presence on all of them in addition to Twitter or X for a better part of a year now, but it's been really difficult for me to cross-post consistently across platforms for a variety of reasons. I do think there's a software solution now that will help a lot with that. It's very expensive. I'll try and find a way to make it work. So that's from the social media front, that hopefully your experience will improve. But I do think these YouTube office hours are kind of unique in the format and the level of interactiveness and the fact that it really can be responsive literally in real time, within seconds, to things that are happening in the real world, which I really do like that. All of these are, of course, recorded and logged forever, so you can go back and laugh at my awkward pauses or my connectivity problems if you wish, or if there are apparently insects in the background or dogs barking or whatever it is. But you can also, I encourage folks to refer back to it as an archive. I know it's not particularly easy to search, but, I have all of the video content here is a Creative Commons open access license. Anybody can use it for essentially any purpose. That goes for both journalists and anyone else who wants to capture snippets. That's part of my intent in having these conversations, so please do it. But the only other question is whether it makes sense to have a more regular, semi-recurring schedule. I will still do one-off sessions at irregular, short notice times when there's something interesting happening, but I'm wondering if it makes sense to try and consolidate the recurring component of the schedule to a more consistent timing, hour, day of the week, things like that, so that folks can join on a more consistent basis. I'm kind of thinking that perhaps mid-morning Pacific time on Mondays might be when I think about having these recurring sessions. And then, of course, the episodic ones will occur according to what happens in the world, so those are hard to predict. But I might move toward that model if folks think it's a good idea. And with that, I'm going to keep an eye on the potential for some elevated heat in California as we head towards early June. Right now, it doesn't look extreme, but there are pretty strong signals in the ensembles that it is going to get hot across inland areas. Sometimes these events are underestimated in the ensembles at long lead times, so remains to be seen if it's a more significant heat event versus a more modest one, but it does look like the interior west is going to heat up and northern Mexico is going to continue to roast, unfortunately, amid record-breaking heat for the foreseeable future. So that's going to continue for a while. This was a really good, I think, open-ended Ask Me Anything session. The questions were, in fact, very wide-ranging, but essentially all on topic. I know I couldn't get to all of them today. There will be other opportunities. As always, some of these sessions are sort of themed and other ones are pretty open-ended. So I think that's about all I've got for you today. Thanks for joining. Have a good weekend. And I will probably have another live session next week, time TBD. It won't be Monday next week because of the holiday, so stay tuned for timing sometime between probably Tuesday and Friday. All right, everybody. Good to see you all, and until next time.